Now we're on to question 7. Question 7 is the first context and applications question. So it's the first problem solving question. It's worth 50 marks. There are 4 problem solving questions and you will get marked on your best 3 out of 4. Okay, let's have a look at it. The blade of a windmill takes 8 seconds to make a full rotation. At the lowest point, the blade is 0.5 meters from the ground. At the highest point, the end of the blade is 6.5 meters from the ground. Write down an equation for the central line of the function. Part 2 is going to say write down the period of the rotation of the blade, and part 3 is going to start about asking you about the equation. Now, the very first thing I would say to students is this. A lot of students find this kind of question a bit complicated at the start. They need to do a good bit of practice of it before they get familiar with going from the information and generating the function, etc. What I would always say to students is this. If you are asked to plot the function as you are here in part B, I would do that at the start, because from that then it's actually sometimes quite easy to write down things like the equation for the central line of the function, and then to write down the period and the range and things like that. And that would be the case here as well. So I'll start off going from part A, but for students, I'm often very happy to see them starting off with part B. Okay, write down the equation for the central line of the function. So in our case, we're going to have a periodic function here. It's going to go like that. What we're looking for is the equation of the midline, and it should be a horizontal line. So write down the equation of the central line of the function. Because we're going from a lowest point of 0.5 to a highest point of 6.5, it's going to be halfway between those two. So you can say 0.5 plus 6.5 is 7 divided by 2 is 3.5, or you can work out the amplitude. Well, the amplitude is found by getting the difference between the max and the min, 6.5 minus 0.5, which is 6, divide that by 2, which is 3. So your amplitude, which would be the difference between the highest point and the lowest point, the highest point and the midline, I should say, the highest point and the midline and the lowest point. In both cases, that should be 3 if I draw my diagram correctly. So that'd be your amplitude. Your midway line, well, you can go from your lowest point, 0.5, add the amplitude of 3, and you're going to get to 3.5. So in our case here, because we're going to be dealing with a horizontal line, y would be equal to 3.5. We'll see a diagram for that in a moment, and that'll make it all the clearer. Write down the period of the rotation of the blade. Well, in this case, this is actually quite an easy question because it gives us the answer. It says that it takes 8 seconds for a full rotation. And that's what the period is. How long does it take to get back to the same place in the cycle? So it takes 8 seconds to make a full rotation. So the period is 8 seconds. Simple as that. Okay, that's 10 marks. So easy once you know how, but I can understand sometimes students find it a bit complicated. If the windmill starts at the highest point, explain why the rotation of the blade could be modeled using this equation. H of t, h for height, equals 3.5 plus 3 cos pi over 4t. If I just click on here for a moment until I get to my graph, okay, and I go back to the explanation now. So this is my function, h of t equals 3.5 plus cos plus 3.5 plus 3 times, let me give myself a bit more room here, h of t equals 3.5 plus 3 cos pi over 4t. Okay, and I'll explain why that function is exactly like that in a moment. But let's just say if we had a different function, if we had f of t equals just 3 cos pi over 4t, if that was the case, well, when t would be equal to 0, then the cos of pi over 4 times 0, well, if it was f of t, we'd have 3 times the cos of pi over 4 times 0. And pi over 4 times 0 is 0. The cos of 0 would be 1. So 3 times 1 would be 3. So if that was the function, you'd be here at the point 0, 3. And then if you had f of 4, so when t would be 4, you get 3 times cos pi over 4 times 4. Pi over 4 times 4 would be pi. The cos of pi would be minus 1. 3 times minus 1 would be minus 3. So you'll be down here. Okay, so this would be the function. It might even dip a little bit lower than that here. And you would rotate back upwards, back downwards, and back up again. Okay, so if there was no 3.5, that would be the function you would be dealing with. Okay. However, of course, we do have the 3.5. So therefore, for that reason, the whole graph is shifted vertically by 3.5 units. So it's starting at its maximum point because it's a cosine function rather than a sine function. A sine function would start at its kind of midline, but the cosine graph, when t is equal to 0, you're going to have the highest point. So therefore, it's starting at its highest point, and its highest point is 6.5 because the graph is shifted vertically by 3.5 units from what it would be if it was just this guy. Okay, we can work out the period. We know the period is 8 seconds. We can figure out our highest point is 6.5, our lowest point is 0.5, our amplitude is going to be 6.5 minus 0.5 divided by 2, it's going to be 3 meters. So that's the difference again between the midline and the top, and the midline and the bottom is going to be 3. And again, we know that our midline is 3.5, so it's going to rotate around that. In our case, we're told the period is equal to 8 seconds. So if we start off at 6.5, after 8 seconds, we're going to be back up at 6.5. Halfway between that, after 4 seconds, we're going to be at our minimum. And again, after another 4 seconds, after 12 seconds in total, we're going to be back down at our minimum. Okay, so with using all that information, I suppose just to confirm why this is pi over 4t, that we know that if you have the graph, again, if you have a graph of, let's just say f of t equals a plus b times the cosine of ct, we know that the period is equal to 2 pi divided by c radians, where c is the coefficient on the variable within the cosine part or the sine part. So 2 pi over c. So in our case, we're told that the period is 8. So 2 pi divided by c is equal to 8. We're going to isolate c. So c is equal to 2 pi divided by 8. So c is going to be pi over 4. And that's where the pi over 4 comes from here. So put it all together, we have our midline of 3.5. We have our amplitude of 3. We have our period of pi over 4. And it's a cosine function because it starts at the maximum point. Okay, I hope that all makes sense. All right, let's keep going. As I said to you, a lot of times I'm happy to see students start at this point here, part B. Use the height function h of t to show the height for the blade for the first 8 seconds. So literally you're just, the Casios can use mode 3, the new Sharps can use mode 2. Type in your function, of course, in radian mode, start 0, end 8, steps of 1, and you got your table filled in and you get 10 marks for that. So that's quite easy, isn't it? Then we're going to draw the graph. So we're going to plot the graph. So we have our midline again of 3.5, our lowest point of 0.5, our maximum point of 6.5. So there we go. That's our function. And again, that's another 10 marks. And then it says use integration. So we're just thrown back in here into a bit of paper 1 material. So, you know, they do like to mix it up a little bit. So you have to be ready for that. Use integration to find the average height of the blade over the first 8 seconds of its turning. Give your answer correct to 1 decimal place. So you're given the clue here that it's integration, but as soon as it says average height, you're planning on using your average value function. So the average value is 1 all over b minus a times the integral from b to a of f of x dx. So in our case, our function f of x, so like that's the formula, but our one is going to be 3.5 times 3 times cos pi over 4t. And of course, in the average value function, it says dx, but we're integrating with respect to t. So t is our variable. Our limits, our upper limit is 8. Our lower limit is 0 because it's the first 8 seconds. So b is 8, a is 0. 8 minus 0, of course, is going to be 8. Now here is the bit where we're doing the actual integration. 3.5 will integrate to be 3.5t. 3 cos pi over 4t, while cos will integrate to give you sine. So 3 cos pi over 4t will integrate to give you 3 sine pi over 4t. But because it's not just t here, because it's not just t, because there is a coefficient pi over 4t, with integration we must divide by the differential of pi over 4t. So we have pi over 4t, and that would differentiate to be pi over 4. In integration, we must divide by that differential. So we're dividing by pi over 4. We have our limits from 8 to 0, and we're going to multiply by 1 over 8. So we put that all in here into the function. So firstly, I'm putting in 8 for t, and I'm going to get 3.5 times 8 plus 12 times the sine. Pi over 4 times 8 is going to give me 2 pi, and where the 12 came from was the 3 divided by the pi over 4. So that becomes 12 over pi. I'm going to then apply my limit for the 0 as well. I know I'm going to be subtracting here. So when I put in 0, everything disappears because the sign of 0 is going to be 0. And that makes my life a bit handy since all this part here disappears. And I'm then going to put it all into the calculator, and I end up getting 3.5. And again, all of this part, you might be wondering, how did it work out so nicely? This part here all disappears as well because the sine of 2 pi is also 0. And so we get my answer of 3.5 meters. And you might think, oh, I've seen that number before. Of course, because it's the midline, and the midline is the average height. So to a certain extent, you knew that. However, you did have to use the average value formula to get it and to show it, because it was needed for full marks, because that was the instruction that you were given. Okay, so for students who were good at their trigonometry, I think that could have been a pretty good question for you and a good start to the problem solving questions.